Hello there, ICS2O folks. This lesson, are we actually programming? I'm wondering if you're thinking that at this point, the scratch that we've done, it just feels like we're playing a video game almost. Yeah, maybe we can make the cat do some weird things, and it's pretty, it's almost too fun to be actually what what we would consider programming programming a computer. But we're gonna have this little lesson. Um, to try and convince you that yeah, there is some programming actually going on. There's some computer science going on, um, and so hopefully you've got this smart notebook note in front of you. We're going to fill it in as we go, um, and you might or might not have Scratch open. You should have some Scratch open here because what we're going to be doing is looking at some of the blocks and how that translates back to other programming languages. So we kind of have a chart here, the programming concept, what it looks like in Scratch, and what the written code might look like. Now, this written code that we're going to be writing is just kind of made up by me. It's not any specific language or anything like that. It's not Turing or it's not JavaScript or whatever. It's just basically what we would call pseudocode, which kind of looks like English and it kind of looks like all the other languages too. So an example is variable assignment. So a lot of times we have, in computer assignments, we get the computer to store values in the variable. And I'm going to type some stuff in here and you're going to type along. I'm going to change the font here so it's a little bit smaller and you'll see it'll look weird, but we'll fix it up later. So um, here we go. Computer memory is set aside, given a name, then assigned a value. And this is kind of the most basic of computer science stuff is storing stuff in memory. That's actually still too big. I'm going to change this again to 20 so it'll fit nice. There. Now that fits nice in our chart. What does this sort of thing look like? And x equals negative 133. Well, that looks like code, right? That kind of, well, it looks like math, but it looks like code. Where does that happen in Scratch? Well, notice that, see if I can make this a little bit bigger so we can see the stage. When I click on the cat sprite, and you don't have this, by the way, but you'll have the Scratch cat somewhere. Right there, it says x is negative 133 and y equals negative 180. So what we're going to do here is we're going to use the little photograph tool and grab little pictures of Scratch so we can show that it's commands actually. There's x equals negative 133. And notice what I did there is I clicked on the motion thing and clicked on the X position, so it's actually printing out to the screen, right? And I copied that, and we'll put it in the right spot in a minute. When I grab the Scratch cat and put them somewhere else, I'm actually assigning the X position and the Y position, right? You notice that it's changing it as I go. Sure, I'm not typing actual commands x equals negative 121, but it still means the same thing. I'm still accomplishing the same stuff. So let's go back to our smartboard thing, and we're going to put those two things in there. You need to use your pointer tool there, Restall. Get it right. Blow that up so we can see it a little bit. And so there we go. Now, what's actually going on in the computer, and I'm going to use my arrow tool here, just so I can point and talk about these pieces. When I say x equals, the left-hand side of a computer code command is actually, that's like the memory position. This is the variable, which is what we would think of it in math class, but it's also the memory spot, right? So there's a memory spot that the computer will remember as x, okay? And then the value stored in there is negative 133. So in memory, the computer calls it X, and in there the value is stored there. Okay, so let's see, right there, I'm going to write, now this is big font, but I'm going to say that this is just the value stored. And I know it looks goofy, we just need to change the font so it's a little bit smaller. There, dandy. Say, okay, fine, rest all, but you've got another sprite there. And this sprite, if I click on it, it's got another X value. How does the computer keep it straight? I've got an X value for the computer. I've got the helicopter, and I've got an X value for the cat. Right? They're different, and the computer's got to keep it straight. They're both called X. How does that work out? Well, I mean, it's not that hard. All we'd have to do is maybe do something like this. For instance, I might call it the cat dot x equals negative 133. But, and I'm going to press Control and then click and drag that just so I get a copy of it, and then I'm going to change this to helicopter. Well, the helicopter value wasn't 133. What was it? Doesn't matter, but it wasn't 133. It was 148. And so that way, we know we're talking about the x coordinate of the helicopter. We're talking about the x coordinate of the cat, and the computer can keep it straight. It's no problem. One thing that I want to mention is that this variable assignment, you've actually seen, probably, depending on how far you are, other places. There's that variable thing. We can actually make a variable and decide on what we want to call it. Let's call it score. We say OK, and then it says, oh, there's a score thing on there. And now the score assignment, notice I've set the score to 0. That's a variable assignment. Score equals 0. So I'm going to take a picture of that and include that. Why not? This is actually one of the spots where Scratch feels a lot like other programming languages. This idea of a variable. Can I squish that in there? Sure I can. And notice this isn't a score that has to do with the helicopter or the cat. This is just a plain old score. Score equals 0. And we'll see different languages actually, the syntax, how we put a command together looks a little bit different, but we get the idea. Okay, Scratch does variables. Fine and dandy. What else does it do? Lots and lots of stuff. It does calculations. So for example, and this is just an example, it will, it changes positions, right? So for instance, back in Scratch, we had, let's just go, and you don't have to do this necessarily. I want to move the cat. Move it 100 steps. Okay, so I'm going to copy that. Well, that feels like an assignment, isn't it? Moving it 100 steps? No, it's a calculation. What we've done is we've taken the x coordinate of the cat and then added 100 to it, right? Whatever it was before, I'll reset it back here, try and get it around what was negative 133 to begin. Bam. And then when I click on that, now it's added 100 to it. I do it again, it's going to add another 100 to it. It's doing a calculation. We didn't realize that that's what it was doing, but it was doing a calculation. So that move 100 steps is actually a calculation, and that one I actually wrote in there for you. But I want to mention and write in here that that's one of our calculations that Scratch does. It change position, add 100 to the x. I'm going to make that smaller so it looks nicer. The other thing that we did is we changed the score. Add up the score. Right? And it was kind of every time something happens, add up the score. And maybe you don't need to worry about this too much, but we had our variables. Change score by 1. So when I click on this, change score by 1, it went up to 1. Notice that that didn't reassign it. Come here, cat. It didn't reassign it. It added 1 to it. Well, that's a calculation. It went score, take the old score, and add 1 to it. I just want to mention here that this is what the code looks like. This part here, I'm going to use the little pencil tool and put a little swoop. This part gets done first. Okay? So this part gets done first. The right-hand side gets evaluated. Make this nice and small so I can fit it in. This side is done first. And then what happens, it gets calculated, and then the new position is reassigned in the old memory spot. It's not a new memory spot. It's assigned back to the first memory spot. So, and you can almost think of it being resaved in the original memory spot. There's spot. Kind of getting off line here. It's kind of getting hard to read. Let's change the direction of our arrow. You're better at this than me, aren't you? You're doing a good job of your note. There. This side's done first, and then it's reassigned here. So a question might be, what would the score command look like? Well, what we did is we took whatever the score was originally, 0 or 1 or 2, and then add 1 to it. Every time somebody scored, they add 1. So what we did is we had, I'm going to use my, right there, we had score plus 1, right? That's the new calculation, but it was reassigned back to the original spot. Score equals score plus 1. This adds up the score. We didn't realize that that's what it was doing in Scratch, but indeed it was. All right, I don't like the videos running so long, so I'm going to stop here, and we'll pick this up in part 2 very shortly.